let's discuss some basic full-text search and full-text indexing techniques for PostgreSQL. So to do that, let's create a simple table with an ID, serial, title, author, description. These are the 5 best-selling children's books of all time. Let's just go ahead and create the table. Once our table's created, let's just view the table so we can take a look at what we're dealing with. Here we have the 5 titles, the 5 descriptions, and then a simple ID for each of them. Okay, so the very first technique we're going to use 2 TS vector and 2 TS query. So we're going to search for a single column, and we're going to search for a single word in a single column here. So let's go ahead and do this. So this is going to find any record that has the word big inside the description column. Okay, not too complicated. The functions here are new and you can read up on them, but 2 TS vector builds the vector and 2 TS query queries the vector that we've created. Next, let's try searching 2 columns at one time. In order to do this, we're going to add to the 2 TS vector, we're going to add description and title both. And make sure you put a space in between description and title, otherwise it'll concatenate them together and the last word of the description will be added to the first word of the title and it won't work exactly like you want. So here we're going to search for the word little across whether the word little falls in the description field or the title field. We'll go ahead and run this. It's exactly what we need. So there's our description field and our title field. So we've got little over here, and we've got little down here. Pretty simple. Now let's do, again, searching those 2 columns, description and title, but let's do a full text search for 2 different words, but we're going to AND them together. So basically we're saying, show us all the books that have the word little in the description or title somewhere, and they must have the word dream. You'll notice the ampersand is used for AND in this case. So we run this query, and then we have the only record here that contains both little and dream. And you notice we searched for dream, and it picked up dreams. That's because in full text search, it searches the stems of the word. So it would pick up dream, dreams, dreaming, dreamed, etc. Okay, now let's do the same thing, but with an OR query. We want the word little or dream. It's the pipe symbol that we use for OR here. So we'll go ahead and run the same query. Now this gives us 2 different results because it's a little less restrictive than using the AND. And next, let's use an index, so this will perform well across millions of records. You wouldn't really want to do what we're doing here across millions of records or with millions of users because it's not going to perform well, because it has to build this 2 TS vector for every record in your database, and that's going to be slow. So we want to build a query column and build an index on that query. So what we're going to do is we're going to first add a new column to the books table. We're going to call it FTS. You can call the field whatever you want. I call it FTS because that stands for full text search. And you can have multiple columns if you're going to search different combinations of columns in your database. But for now, we're just going to do the one, and it's of type TS vector. So we'll go ahead and add that column to the database. And the first thing we want to do is just take a look at that column to show you that once we added it, it's null. There's nothing in it. So we need to populate the column with data in order to be able to index on it and search on it. So to populate it, we're going to say update books, set FTS, our new column 2, and then the TS vector just like we did before, 2 underbar TS vector. And then we're going to use the description and a space and the title field. We'll concatenate all that together just like we have in the past. Now, important thing to note here, once we've run this, the FTS column now always allows us to only search for description and title. You would have to create multiple columns if you wanted to search just a single field in the database, or if you wanted to use more. But for right now, we're standardizing on all of our searches are looking in the description and title fields. Now that the field is populated, let's take a look at what it looks like. It's interesting, I'm curious about what this looks like, but you would never want to update this or interact with your full text search field directly. But you can kind of see the stems, ANIM for animal, LITTL. I'm not sure how that works under the hood. I'm not an expert, but it's very complex in its language handling, and again, it knows how to turn those stems into a valid query. So now let's do a search using that index. It's very similar to what we were doing before. Select star from books where FTS. We're just using this search column in all of our queries, and we're going to do the same query as before, where the book contains the words little and the word dream. And there's the same result that we had before, only this will work much faster and across, again, as many records as you want to throw at this table. Now, it's important to note that once this index is created, it has to be updated anytime you change the data. So we don't need to do this now, but if we were to add a new book to the list, we're going to need to update books and set FTS to the same vector like we did before, where FTS is null. Or if I were to update a specific record, let's say I change the title or the description of any record, that record has to have its FTS field recalculated. Otherwise, your index will be out of date. In addition to the operators we looked at before, ampersand for and pipe symbol for or, there's a whole page of operators you can look at in the documentation for PostgreSQL. But here are some that I find really useful. If you wanted to do an exact match, so you want to look for all books that contain the exact phrase big dreams, you'd say big less than dash greater than dreams. And you can chain these together. If you wanted to add another word, you'd add it like this. Oops. Less than dash greater than another word. And you can do as many as you want here, but that'll find only the exact match. So not only does it have to have the word big and dreams, they have to be right next to each other. You can also use the proximity operator, this is basically a proximity operator, but it means right next to each other. But you want to say find two words, up to 2 words apart. So you could say year and then less than to greater than school. And this will find year, school, or year of school, year in school. And this number can go as high as you want. You can say 5 if you want to say up to 5 words apart. So it finds words that are in proximity or near one another. You can negate a query term by using the bang symbol. So if I want to look for all books that have the word big but do not have the word little, I'd use a bang in front of the little. And you can also mix and match these query terms by using parentheses, and you can use the negate as well. So you can say find all records where it contains food and eat, or it contains the words eat and vegetable, and it does not contain the word school. So you can get as complex as you want in how you mix and match these query terms. This has been full text search and full text indexing for PostgreSQL.